Hi, my name is Brian, and welcome to this week's Ask Brian part of our weekly newsletter. This week, I have kind of a simple question to answer, one that's covered in our regression class, but I thought I would cover it here as well. So, our newsletter is called Monday Morning Data Science. If you want to sign up for it, there's a link in the video description below. So, someone asked, how do I know when to scale regressors? So, just to orient ourselves, let's draw out this particular model right here with just two regressors where we have an expected y is equal to an intercept plus one regressor times its coefficient plus another regressor times its coefficient. Okay, now let's suppose our first regressor is something like height in meters. So this one is height in meters, and this one is, say, weight in kilograms. Okay, so if we center our regressors or shift them in any way, that doesn't change much other than the interpretation of the intercept. And the reason you might want to do this is if you just have a simple linear regression, if your intercept is down here, let's say your x is blood pressure, and no one has a zero blood pressure that's alive, okay? So if you're studying some y, right, you might want to, oh, my battery's running out, so I'll have to be quick. You might want to move your center to right there to the average blood pressure where your intercept will be interpreted. It doesn't change anything with the model fit or anything like that, but it does change the interpretation of the intercept, which is useful because zero blood pressure isn't that meaningful. So that's why we shift. And then what happens when we scale is it simply inversely scales the coefficient, okay? And so what we wind up doing, okay, when we do a unit change, okay, is it doesn't change the predictability of our model, or the prediction performance of our model, but it does multiply. When we multiply our regressor, it has a multiplicative effect on our coefficients. So why might we want to do that? What are our coefficients interpreted as is a good question. So our coefficients are, let's say beta 1 is interpreted as the expected change in y per unit change in x. So if our x1 is height in meters, then our beta 1 is the expected change in the response in whatever units the response is measured per 1 unit per 1 meter change in x. Okay, so sometimes we might want to rescale our regressors because maybe meters isn't so small. Maybe our y is some sort of, our x, is some sort of astronomical distance, and it's just silly to have recorded it in meters, so we might want to, multiply it by a factor. But I think what the person is more asking about here is when you rescale your regressor by dividing by the standard deviation. So then the units of our regressor are in standard deviation units. And sometimes we do that. See, point one here is because sometimes these scaled units are just more interpretable. Sometimes our regressors don't have meaningful units to begin with, and by converting them to having standard deviation units, our betas are more interpretable than they are in the natural scale. Of course, if you like the interpretation on the natural scale, then don't convert your betas to your x to having standard deviation units. So that's one reason. Another reason that you often see is if you want to compare the coefficient values across regressors, if we want to compare beta 1, the magnitude of beta 1 and the magnitude of beta 2, we can't do that because, right, the units are not the same if we haven't rescaled our x's. So this comes up a lot in kind of some modern statistical problems. So sometimes when people want to do stuff like the so-called lasso, they want to constrain, the absolute value of the sum of beta 1 and beta 2, maybe times some constraint parameter, lambda. Well, you can't add these two things unless they have similar units. So for them to have similar units, remember they're defined this way, we have to redefine our x's to have the same units. One way to do that is to have them both have standard deviation units. Okay, so the two biggest reasons I think why you might want to scale your x's by the standard deviation. One is if the scaled units are more interpretable for your problem, and two, if for whatever the reason you actually want to compare the magnitude of the beta values across regressors. Okay, well, that's a relatively simple question to answer. If you have any further comments, certainly put them in the comment section, and I'll see you next week.